Good morning, my beautiful students. You are welcome to yet another interesting and one of the most fascinating subjects you can ever engage in, and that is basic science. I'm so glad to reach you through this medium at the moment, and I want you to make maximum use of this opportunity. Make sure you have your writing materials handy, because you're going to be writing some interesting things. In this basic science for today, we are going to be treating a very interesting topic that says sound wave. Sound wave. As I'm talking to you, you are hearing me by the principle of the transmission of sound waves. And it is being produced from my vocal cords. As I articulate my vocal cords, it vibrates, and from the vibration of my vocal cords, sound is produced, various sounds that can distinguish the words that I speak, and then transmit it through the wave medium, which the air carries into the device that I am using, and through some electronic processes, it is being transmitted to you in your various homes and in your various home devices, which you are using now to go along in this class. You are highly welcome for this. And we are going to be treating the following specific objectives as we go forward. First and foremost, we are going to have, in our specific objectives, at the end of this lesson, I should be able to define sound and sound wave, state the various means of sound production, discuss sound transmission, and describe the hearing processes in the human ear. The first one, we're going to define sound so that you can understand what sound is all about, and sound wave. Then the second one, state the various means of sound production. What are those means by which sound can be produced? Because there is the production of sound, and something brings about sound into effect. And we're going to be looking into that. Then the next thing we're going to discuss is how is sound being transmitted from one point to another? How is sound being transmitted from one point to another? And then the last thing we're going to look at will be to describe the hearing processes in the human ear. The hearing processes. How is it that your ear is able to detect sound and transmit it, that you will understand what type of sound you are listening to? All right, so we're going to be describing all these things as we go on in this topic. Now, let's define sound. What is sound? Sound can be defined as an audible effect from a vibrating body. It can be defined as an audible effect, something that can be dictated in form of sound from a vibrating body. As a matter of fact, sound cannot be produced without the vibration of an object or of a body, be it a living body or a non-living body. All right? So when a body vibrates, it produces sound. The sound might be very minute, it might be so small, it can be loud. Of course, there are different ranges of sound waves, and their characteristics like pitches of sound, the pitch of sound, the different wavelengths, and the rest of them. But all in all, sound is produced when a body vibrates. All right. So, according to what you have on your screen, any object in a vibrating mode or condition produces sound. Okay? Now, you can even demonstrate it by yourself as you're seated in your homes and listening to this lecture. You can use your pen and tap on your table. When you use your pen and tap on your table, it causes vibration between the two bodies. That is between your pen and the table, and automatically is going to give off a sound effect of which you're going to hear. And that sound is carried by the wave of sound, which is conveyed from that point of impact to your ear through the air. So we are still going to be looking at why these things happen and how it happens. All right? So this sound is detectable by the ear of living organisms. However, those that cannot do so, there are some living organisms that don't have specialized sense organ of hearing, but they have special parts of their body for detection of vibration. They have very special parts of their body for detection of vibration. And as a question, I want you to mention 2 animals that use special body parts other than their ear to detect sound. 2 animals that use special body parts other than the ear to detect sound wave. Let's go on. Sound wave can be defined as the energy produced when bodies vibrate. All right? Sound wave can be defined as the energy produced when bodies vibrate. So, at the instance of the vibration of a body, sound wave is produced. And so that's the definition of sound wave. The energy that emanates, that comes out from the vibration of a body is the sound wave. All right, now let's go forward and find out some things about sound. As we're going to see, how is sound produced, or how can sound be produced? There are so many means through which sound can be produced. As you can see on your screen, sound can be produced when the following objects or bodies vibrate. What are those things that happen and sound comes to effect? Number 1, musical instruments. If you have a guitar, you know that that guitar will not produce any sound until you strike the chord. If you have drums, the drum will not produce any effect until you hit the drum. And there is a vibratory effect which makes sound to proceed. So if you look on your screen as you're watching, you find out that there is, at the right hand side of your screen, you can see a musician, and what is he doing? He's playing an instrument known as saxophone. Now, how is it that he's able to produce sound from the saxophone? Because by pushing in air, he is forcefully pushing in air into the instrument, and that air causes some parts of the saxophone to begin to vibrate. And as this part of the saxophone vibrates, sound automatically proceeds from inside the saxophone, and you are able to hear it because the air around the musician, as he plays the instrument, the air around him carries the wave up to your ear, and you're able to hear the sound of a saxophone. That is also applicable to every musical instrument. Whatever it might be, for there to be sound, there must be a vibration of a part of it or the entire of it. So musical instruments can be used to produce sound. Another thing is what is known as a tuning fork. A tuning fork is what is used in the lab to produce sound. It's made up of metal. And the next one, by striking it on a table, it produces sound. The next one is metallic objects. Assuming you're holding a metal in your hands as you move along, and by mistake it falls off your hand to the floor, it's going to vibrate on contact with the floor and it's going to produce some sounds. Or you strike a metallic object with another solid object, it's going to produce sound. Now, the splashing of water can also produce sound. And you can get if you visit somewhere like the ocean or the sea or the beach, like we have it around Lagos, where we have the Bar Beach. If you go there, you see how the waves of the ocean water is moving and is coming with some sound effect. When it hits the shore, whether on a rock or on any other material, is going to give out a sound. A sound effect is produced. So splashing water can produce sound. Rain droplets, when the rain is falling, it makes a lot of noise, and that is sound being produced. Now, when a wind is blowing, a wild wind is blowing, it carries with it sound, all right? Because it's in motion, as it's moving, is producing the sound, and it comes in contact with other objects in the atmosphere. It produces a lot of sound. Now, also a baby that is crying is also making sound. And I know that you are very much aware of it, that when babies cry, they make very high pitch of sound. All right? So babies crying produces sound. And of course, from a human perspective, the vocal cord in our trachea, helps to produce what? Sound when they vibrate. Another thing that can produce sound are things like vehicles. When a vehicle is moving, sound is being produced. When the engine is on, it produces a lot of sound. Now, gunshot is another thing that can give out a very loud noise, a very loud sound. And the moment the trigger is pulled, then there is a vibration that is caused to the contact of the bullet inside the gun. And it gives us a very loud sound that the ear can be able to detect. At times, depending on the level of the sound, it can even cause damage to the ear if you're too close to a gunshot sound. So gunshots produce a lot of sound, even the explosion of bombs and the rest of them. Now, the last thing I want to point out as a means of producing sound, I've mentioned it before, animals, of course. Now, a lion that roars can be heard miles away, not even a short distance. I mean, miles away, you can hear just a single lion roaring so much. It produces a lot of sound from its vocal cord, of which other lions in other territories tend to hear, and they tend to respond according to their relationship. Now, there are so many other things that can produce sound apart from these ones I mentioned. You can mention the rest on your own. You can mention 10 more or 20 more things that can produce sound. Now, the next thing we are going to look into is sound transmission. How is sound being transmitted? How can it be moved from one point, from the point where it is produced, to another point where it can reach or be received? Sound can only be transmitted through a medium and never through a vacuum. What does that imply? For sound to move from one point to another, it requires a medium. What do you mean by medium? Now, there are 3 states of matter. We have the solid state, the liquid state, and the gaseous state. Now, the air is in the gaseous state. The air helps to carry sound wave. It conveys. It's like something that helps to move sound from the point of production to the point of reception. Sound moves through air, and it is very, very practical that sound moves through air. When you are very close to a friend and 2 of you are discussing, you don't connect any wire between you and your friend for him to hear you. Even if your friend is some distance, some distances away from you, and you begin to speak, it is the air between 2 of you, between 2 of your bodies. The air conveys whatever you are saying to your friend, and your friend is able to hear what you're saying. Now, if you remove that air from between you and your friend, your friend will not hear you, no matter how you shout. That is to tell us that in a vacuum, in other words, where there is no presence of any form of matter, sound can never be transmitted. It cannot be moved from point of production to point of reception. All right? So that is what we meant when we say that sound can only be transmitted through a medium. There must be a medium of matter to convey the wave of sound. It can never work in a vacuum. And another practical example of what I've just told you is that in the outer space, that is where the astronauts go to before they reach any planet. In that outer space, there is nothing like air in that place. So if two astronauts are discussing up there, they need another form of communication gadget. But if they are talking literally to one another in that outer space, no matter how they shout, even if they let them use gunshots to make the other person to hear, nobody will hear. No matter how close the person is to the other, they cannot hear one another because there is the absence of air to help and convey the sound wave. So sound travels through air. We're going to be seeing it in our next slide. The next thing that happens is that sound moves through liquids. Sound can move through liquids. We will also see that because inside the water, some aquatic organisms convey and communicate with one another through sound waves. One of them is the killer whale. The killer whale, which is known as the orca, can communicate to its fellow inside the water through sound. Other whales also, dolphins, even shark, they can communicate with one another through sound waves, which they produce in water. For the ones that cannot produce, they will cause vibration in water, which can be detected by another aquatic organism. We'll be seeing it in detail. The other one is solid. Sound wave can also move through solid matter. All right, we'll be seeing it. Let's go to the next slide and see all these things. Now, for that of air, you find out that based on what you're looking at on your screen, sound is produced by this speaker here. The speaker produced this sound, and through the medium of air and gases, the sound wave is being carried gradually until it reaches the ear, where the ear will now detect the sound and be able to know what is coming in the sound wave. So sound can be moved through air. The next thing we're going to look at is that of aquatic medium, that sound can move in liquid medium. Now, based on what is on your screen, you can see that that is a dolphin. And a dolphin produces sound. Also, shark can do that. You know, most especially when the shark wants to locate the prey it wants to feed on. And at a point, depending on what is called turbidity, the clarity of view in water, if it is not too clear, but a shark is going after a prey, for the shark to be able to pinpoint and target the prey very well, it can let off some vibratory wave from its mouth and from its body. That vibratory wave will move towards the direction of the prey. And when it hits the body of the prey, there's going to be what is called reflection of that sound wave produced by the shark or the dolphin. So when it hits the body of the other fish it wants to feed on, then the sound wave will be reflected back to the shark. As you can see on your screen, it was reflected back to the predator. That in this case, that's the dolphin, and the shark can also operate in the same way. When it comes back to the shark, with it, the shark will know, yes, this is where the prey is, or this is where the prey is not, so that it can move towards that part and strike the prey and feed on it. And that's how sharks survive in the ocean. They use sound waves to detect the direction of their prey. So sound can move in liquid. All right, an interesting topic indeed. The next one is that sound can be transmitted through solid medium. Now on your screen, you can see two friends with a metal rod placed on the table. One of the individuals is now making a sound, creating sound with a hammer at one end of the rod, so that the other of his fellow can place down his ear towards the opposite end of the rod. The moment he makes the sound with the hammer at the other end, the friend is going to hear the sound at the opposite end of the rod. And that is to tell you that sound can move through solid. Sound can move through solid. And you know that the moment he hits the rod, it's going to vibrate as well. So, as taking you back to our definition, where you found out that vibratory bodies produce sound, this is also another typical example to support the scientific fact that vibratory bodies produce sound. So, sound moves through solid materials. All right. Now, the next thing we are going to look at is that sound has some characteristics, but I will only mention this particular one. In your assignment, you're going to be mentioning some other ones. Now, sound wave can be reflected. There is the reflection of sound wave. And what do we mean by reflection? Reflection simply means to bounce back. To bounce back means to be reflected. After hitting a surface or hitting another matter, for it to bounce back, you can say it is reflection. So sound wave can be reflected, as we are going to see. Now on your screen, you can see the man who made sound from his vocal cords, and the waves moved towards the object, which is in red color, still on your screen. So the moment he speaks something like wall, I can liken that object to be the wall. So when this man speaks directly to a wall, this normally happens when you are inside a large hall and there is nobody there, people are not there, there are not much things inside the hall, it's just an empty hall. The moment you speak or you shout in that hall, after some seconds you've spoken, what will happen is that you will hear what you have said coming back to you in form of echo. Now, that phenomenon is called echo. Sound waves can be reflected when it falls on a surface, especially on a surface like walls, even in rocks and caves. When you go inside a cave, you know the cave is so big and almost void of other materials. So the moment you speak, after a few seconds, you will hear the same sound you made some seconds back. You will hear it again. It will echo back to you. What happened? What went out of your vocal cords through your mouth has hit the walls, the rocks of the cave, and is bouncing back to you. And that is why you hear it in that effect known as echo. So the man on your screen has spoken, made some production from his vocal cords. The thing has hit the red wall there. And then the dotted waves coming back towards him are the reflected sound waves. Just as you can see, what this man has done, he has produced the sound. The waves moved towards the wall and came back to him as well. So that is it about the reflection of sound waves. Sound can be reflected. Now, we're going to be looking at the next thing on our specific objective, which is sound transmission processes in the human ear. How is sound dictated by the human ear? First and foremost, you have to know that the ear has three different regions, three major regions. And what are those three major regions of the ear? The ear is divided into what is known as the outer ear and the middle ear. Then the third portion is known as the inner ear. So we have outer ear, middle ear, inner ear. As you can see on your screen, I'm going to be showing you what this outer portion is. Now, looking at this, you can see the pinna. Look at the pinna here as I'm pointing it out for you on the screen. And then the pinna and the ear canal, or what is known as the auditory external auditory meatus. This is external auditory meatus, or you call it the ear canal. Two of them, that is the pinna and the ear canal, make up what is the outer ear. And what is the function of this outer ear? Their function is to collect sound waves. It's for collection of sound wave. That is why your pinna has so many curves. All right? The actual reason for all these curved shapes in your pinna is to be able, just like your cable dishes that you use to get your cable networks, you know, they have so many curves in them. They help to trap waves. So for the human, all these curves in his pinna are meant to collect sound wave. And then it is channeled through the ear canal. The ear canal will now pass it on to what is known as the middle ear. The middle ear is made up of bones, little bones called ossicles, and a cone-like shaped object known as the tympanic membrane. The tympanic membrane, as you can see, is joined to the ossicles here. Now, what is the function of the middle ear? What is the function of the middle ear? The middle ear is there to amplify the sound wave that you have received. The sound wave that was passed on to you, you had to receive. All right? So when the sound wave comes to the middle ear, it is amplified. The sound is increased. And when it is increased, it is passed on to the inner ear. The inner ear is where you have the cochlea, the main organ that dictates sound waves. Once the sound reaches the cochlea takes the impulses from the sound and push it off to what is known as the auditory nerves. The auditory nerves, they are part of the inner ear. The auditory nerves will now take that sound impulse to your brain, where your brain will receive and interpret what you are hearing, to tell you whether what you're hearing is a sound that you should stay back and listen to, like a wonderful music, or a sound that is so scary that you should run for your dear life, like the roaring of a lion beside you. My dear, are you still going to be sitting there? You take on your heels. So the ear helps us a lot. It helps us to dictate sound. So in these few descriptions I've given you about the transmission of sound waves in the ear, I hope you'll be able to understand that next time you hear sound, you can say that this is what is going on within your ear, and your brain is also part of it, the central nervous system that helps you to interpret what you hear. Now, the next thing I want you to do is to watch a little clip, a little video on sound, and it will help to explain further things about sound and sound waves to you as you watch.
Transmission of sound. Every sound is produced by a vibration. Vibration is the back and forth movement of an object. As you speak, vibrations are produced by the vocal cords in the throat. You can hear only when the sound energy reaches your ears. But how does sound energy travel? Wonder how that works? Come, let's go across to Dr. Zook. Sound energy travels in the form of sound waves. There are mainly two types of waves, transverse wave and longitudinal wave. Let us see how waves travel. We can use a slinky spring to observe both types of waves. Emily is holding one side of the slinky. while Dr. Zook is holding the other end. With a quick upward flick of the wrist, Dr. Zook has sent energy traveling through the slinky. Notice how the slinky moves? This is a transverse wave. In a transverse wave, the particles vibrate at a right angle to the direction of the wave. The wave traveled from Dr. Zook to Emily and back. Now let's see what a longitudinal wave looks like. Emily is holding one end of the slinky, while Dr. Zook is pulling its other end towards himself, and then pushing it towards Emily. Watch closely, and you will notice that some of the coils crowd close together, and then slowly move farther apart. This is because the vibrations are parallel to the direction of the wave. If the wave moves from right to left, then the particles also vibrate from right to left. This is a longitudinal wave. Sound waves are longitudinal waves. These waves travel at different speeds in different mediums. The medium could be a solid, liquid, or gas. Now let's see how this works. In a solid, the particles are very close together. Sound energy moves as one particle hits the other particle. With the particles being so close together, sound travels quickest through a solid. If we look at particles in a liquid, they appear to be slightly further apart when compared to solid. Thus, sound energy takes a little longer to travel through a liquid. Look at the particles of gas. They are spread out, and hence, sound waves travel most slowly through them. Now we know how sound travels in different media. The vibration of particles produces waves. Wavelength is the distance between two consecutive compressions or rarefactions. The number of waves passing through a point in a second is called frequency, and it is measured in hertz. Sound waves travel in all directions.
Emily?
Sound gets reflected. That is, it bounces back on hitting a solid surface. Bouncing back of sound is called echo. Bouncing back of sound is purposefully used in detecting depth of seabeds. That's amazing, isn't it? Summary. Every sound is produced by a vibration. Vibrations are produced by our vocal cords when we speak. There are two types of waves, transverse wave and longitudinal wave. In a transverse wave, the particles vibrate at a right angle to the direction of the wave. In a longitudinal wave, vibrations are parallel to the direction of the wave. Sound waves are longitudinal waves. Sound travels quickest through a solid. Wavelength is the distance between two consecutive compressions or rarefactions. The number of waves passing through a point in a second is called frequency, and it is measured in hertz. Bouncing back of sound is called echo.
All right. Now, thank you so much.